Our focus for today is to solve our quadratic equations by graphing. So we had a little bit of experience of this already when we went and we just had a graph to begin with, and we could identify what our x-intercepts, aka our roots, aka our zeros were to our quadratic function. But now we're going to kind of just start by giving you a formula, and you're going to go ahead and graph it in order to figure out what your x-intercepts are. So the first thing you need to make sure you're doing is that your equation is in standard form. In other words, put everything over to the left side of the equation and just leave equals 0 on the right hand side. The next thing you're going to do is you're going to graph your equation. And this follows the same process that we went through all of last unit by graphing your quadratic equation. If you need a little refresher, go back to that video to help you out. Then what you're going to do is you're going to look at where your parabola crosses the x-axis. At what x values are those? Remember, it can cross 2 times, it could hit it once, or not at all. If it never crosses the x-axis, you're going to write that there's no real solution. So for example here, say I already graphed my parabola, and now I'm looking on the x-axis. So it hits at -2, and it hits at +2. So my solutions are x equals -2 and x equals +2. So now let's go ahead and start off. I want to solve x squared plus 6x plus 8 equals 0. So I'm going to start the same way. I want to again know my end behavior and max, because this, if it's a max or min, because I want to know just the general direction of where my graph is going before I go ahead and plot it. So I know that it's going to be going up, and I have a minimum. So I start by finding my vertex again. So I'm taking that -b over 2a. So I do -6 divided by 2 times 1, which is -6 over 2, or -3. Again, I plug back in -3 into my equation in order to figure out my y value. So when I do so, I get -3 squared, which is a 9, 6 times -3, which is -18, and then plus 8. So when I add this together, I get my y value is -1. So I go ahead and I graph that at -1, 2, 3, down 1. I plot my vertex, and then I also plotted my axis of symmetry, because remember, when I plot my axis of symmetry, it's much easier to then go and plot the rest of my points. So now I'm going to do that. I'm going to find the rest of my points. So again, when I start at my vertex, I either can go down 2 or I can go up 2 from my vertex x coordinate. So first I went down, I went -4 and -5. And when I plug those in, I got -4. When x is -4, my y value is 0. When I put in -5, then my y value is 3. When I put in -2, my y value is 0. And when I put in -1, my y value is 3. So I'm going to go ahead and plot those now. So now that I have those plotted, I want to start looking at this and say, okay, does it cross my x-axis anywhere? And the answer should be yes. You should be zoning in on these 2 points here, because that's where my x-axis is. So that being said, my solutions are at x equals -4, because it goes over 1, 2, 3, -4. And then at x equals -2, 1, 2. You can always check that by your graph and then also your table, because you're looking for where your y values are 0. So in this case, it hits my x-axis 2 times, so that's why I have 2 solutions written down here. So let's go to another example. I have x squared plus 4x equals 5. Right now, you should be looking and be like, not everything is over on that left side, which means the first thing I need to do is I'm going to need to subtract 5 to this side, so then I have 0 left over. So your new equation is x squared plus 4x minus 5 equals 0, which is exactly how I have it written here. So again, the first step, I want to know the general shape of my graph, so I know it's going to be opening up, and I'm going to have a minimum. So I first find my vertex. My vertex is going to be a -4 divided by 2 times 1, which is a -2. I'm going to plug that back into my equation, and I'll get -9 as my y value. So I went ahead and I plotted -2, -9, and I put on my axis of symmetry at x equals -2, because remember, that has to go through my vertex. And now I'm going to start figuring out my other points. Okay, so I put in -2, -9 as my vertex, and then I went 2 points below, and I went 2 points above. And again, you don't have to do the 2 points below and 2 points above. You can just choose to do 2 points in one direction, and then use that axis of symmetry to get to the other direction. So if you notice here, I graphed -3, -8. I graph -4, -5, and then I graph their reflection points. So you should be looking at this and saying, well, wait a second, I graphed it, but I haven't gotten to my x-axis yet. And granted, if I were to draw in my line, I still wouldn't have a clear picture of where exactly it crosses this x-axis. And that's okay, because guess what? Just keep going and finding more points and see when you get to that x-axis. So right now, I'm over here on my y-axis at my x-coordinate of 0. So let's go ahead and pick another point. So I picked the point right over. I picked the point 1. When I plug in 1 to this equation here, I get back 0, which is super exciting because look, I now found one of my points here. So if I have a point here, I'm also going to have a point over here. So we went over 1, 2, 3 units to the right. Well, let's think about it. I'm going to have to go over 3 units to the left. So let's see if that actually happens here. It does, okay? So that being said, I have 2 solutions here. And my 2 solutions are x equals -5 and x equals +1. So sometimes it might be the case where you get lucky as you're doing the vertex and automatically within those 2 points below or 2 points above, you might already be on that x-axis. Other times when you're doing it, you might not be on that x-axis yet, in which case, add more points. Now do keep in mind that to some point, you might get a graph in which it will never hit that x-axis. For example, if I was, say, starting at this vertex here, but then I was going down, I would never be hitting the x-axis, in which case, there's no real solution. So keep that in mind as you're doing some of the practice problems next.